Welcome to Strange and Curious Planet, where we dig into the mysteries that refuse to stay buried. If you're fascinated by lost worlds, ancient predators, and the moments when science has to admit it got things wrong, you're in the right place. Before we go any further, take a moment to subscribe to the channel, because what we're about to explore completely overturns what most of us thought we knew about the largest shark to ever live. For decades, Megalodon was portrayed as a supersized great white, an unstoppable monster that ruled the oceans through brute force alone. But recent scientific discoveries tell a very different, far more surprising story. For over a century, Megalodon has been reconstructed almost entirely from teeth, huge, triangular, serrated teeth, some the size of a human hand, were all scientists had to work with. From these fragments, a simple assumption was made: scale up a great white shark, multiply everything by several times, and you've got Megalodon. This image spread everywhere, from textbooks to documentaries, until it became accepted fact. But teeth, it turns out, can be deeply misleading. Shark teeth evolve rapidly and often resemble one another, even in species that behave very differently. As researchers began comparing Megalodon teeth more carefully with those of modern sharks, cracks started to appear in the old model. The bite was enormous, yes, but size alone doesn't dictate how an animal lived, moved, or hunted. One of the most shocking revelations came from studies attempting to reconstruct Megalodon's full body using advanced biomechanical modeling rather than artistic scaling. When scientists analyzed how a giant, great, white-shaped body would actually move through water, they found a problem. A shark built exactly like an oversized great white would be incredibly inefficient at extreme sizes. It would burn massive amounts of energy just to cruise, making it unsustainable as an apex predator. This forced researchers to rethink everything. Instead of a bulky, torpedo-shaped predator built for explosive speed, evidence now suggests Megalodon may have been longer, sleeker, and more elongated, closer in some ways to a lemon shark or even certain extinct whale-like fish. This body plan would have allowed it to glide efficiently through the water, covering vast distances with far less energy. In other words, Megalodon may not have been a constant high-speed hunter, but a strategic, energy-efficient super-predator. Its hunting behavior is also being re-examined. The classic image shows Megalodon charging from below and crushing whales in half with a single bite. While dramatic, this likely wasn't the norm. Bite mark analysis on fossil whale bones tells a more complex story. Many bones show targeted damage to fins, ribs, and tail regions. This suggests Megalodon disabled its prey first, preventing escape, and then fed at leisure, behavior more consistent with calculated ambush than mindless aggression. Even more surprising is what scientists are learning about Megalodon's role in the ecosystem. Rather than simply being a solitary ocean terror, it may have been a stabilizing force. By preying on large, slow-moving whales, Megalodon likely influenced migration patterns and population sizes, shaping marine ecosystems on a global scale. Its disappearance wasn't just the loss of a predator, it was a structural collapse in the ocean's food web. New isotope analysis from fossil teeth has added another twist. Chemical signatures locked inside the enamel suggest Megalodon lived in a wider range of water temperatures than previously believed. This indicates it was far more adaptable than once assumed, capable of moving between warm coastal waters and cooler open oceans. Some evidence even points to nursery zones in shallow seas, where juveniles grew in relative safety before venturing into deeper waters. So if Megalodon was so efficient, adaptable, and successful, why did it disappear? For years, the leading explanation was climate change alone. Cooling oceans and shifting currents were thought to have wiped it out, but recent models suggest climate change was only part of the story. The real shock comes from competition. As Megalodon declined, early ancestors of modern great white sharks and new species of smaller, faster whales began to appear. These whales were quicker, more agile, and harder to ambush. At the same time, emerging predators competed for the same food sources. Megalodon didn't lose because it was weak. It lost because the oceans changed faster than even a perfectly evolved giant could adapt. Perhaps the most important takeaway is this: Megalodon wasn't a freak anomaly. It was a product of its time, precisely adapted to an ancient ocean that no longer exists. Its extinction serves as a warning about how tightly life is bound to environmental balance. When that balance shifts, even the most dominant species can vanish. What we're discovering now is not just that Megalodon was different in shape or behavior, but that our entire understanding of prehistoric oceans has been, well, overly simplistic. The seas of the past were complex, dynamic systems filled with specialized giants, not just oversized versions of modern animals. Megalodon's story isn't one of mindless terror. It's a story of evolution, efficiency, and eventual vulnerability. And honestly, the fact that we're still rewriting it today reminds us of a deeper truth. Science is not a fixed narrative. It evolves, just like life itself. Here on Strange and Curious Planet, we explore these moments where certainty collapses and new understanding emerges. If this changed how you see the ancient oceans and the monsters that once ruled them, subscribe to the channel, share this with fellow history and science enthusiasts, and, stay curious. The past still has secrets, and we're only just beginning to uncover them.